Okay, looking at question number 4, we're asked, do professional golfers play better in the first round? A random sample of golf finalists in the British Open gave the following data for their first and last golf round in the tournament. Okay, we have 9 golfers. We have their score in the first round, and we have their score in the last round. And I don't know nothing about golf, but I do know that the lower your score, the better it is. So we are expecting that the first round will show lower scores than the score on the last round. Okay, so that really begs the question, that's the question down here. Do the data indicate that the population mean score on the last round is higher than the score on the first round? And if that's the case, then yes, professional golfers play better on their first round. Alright, we're asked to use a 5% level of significance, state your hypotheses, and yada yada yada. Now, we are comparing 2 sets of data. We've got scores for the first round of golf, scores for the last round, and really we're comparing these averages to see whether they're the same or different, or in this case, what we really want to know is whether the last round has a higher average than the first round. So we are comparing 2 population means. So anytime I'm comparing 2 population means, I have a choice of running a 2-sample t-test or a paired t-test. The difference being that in a 2-sample t-test, I have to choose my subjects or my samples, whatever it is, randomly and independently, whereas if I'm running a paired t-test, well, the subjects are chosen randomly, but they're not chosen independently. So what is the situation right here? Well, when I look at this, I've got 9 golfers, and for each of these golfers, we have recorded their score on the first round and on the last round. Now that means, in this case, that 73 and the 66, that's a score that's tied to golfer number 1. 68 and 70 is tied to golfer number 2, etc. This is a paired situation, and it's paired because we've only randomly picked 9 golfers, and for each of these 9 golfers, we're doing 2 measurements. One on the first, one on the last round. This would only be a 2-sample t-test if I had picked 9 golfers and recorded their score on the first round, and then picked an entirely different 9 golfers, or however many golfers I like, and measure their score on the last round. Now, of course, it would make no sense to do this independently, because the question is, do people play better on their first round? So that means you've got to compare their first and their last round scores. So this is paired. Alright, anytime it's a paired, we're testing really the average difference. Now, your null hypothesis is that there is no difference in the scores, and good practice says we should indicate how we've defined the difference, and I've defined the difference so it's the score on the last round minus the score on the first. And if that's the case, and I'm trying to prove that golfers do better on the first round, I'm expecting that number, whatever it is, to be smaller than this one. And if that's the case, I'm expecting a positive difference. Okay, we're asked to run this at an alpha of 0.05 or a 5% level of significance. So typically we would calculate the test statistic. Now, to calculate the test statistic, when you go into your notes, you are going to see, hang on now, I got it right here. Here's the test statistic, but in order to calculate it, you need to know the average in the differences, and you need to know the standard deviation of the differences, and N here represents the number of differences. So if we were doing this by scratch, well, kind of by scratch, if we were doing this by hand, let's say, the first thing we'd actually have to do is calculate the differences. Now, if I'm running this from a paired t-test in Minitab, I don't really need to do this. but I'm going to do it anyway because at some point we might need to. Alright, I've set up a column. I'm calling it differences, and I want my differences to be the score on the last round minus the score on the first round. And I say OK to that, and here's my differences. So if I didn't have Minitab to play with, I would have to go calculate the differences, and then I would get the mean and the standard deviation. And there it is there. There's my mean difference, the standard deviation of my differences. Don't be using the 1.50. That's your standard error. And we have 9 differences. So these are the numbers that are reflected in my test statistic. Now, I have my test statistic, and if I come back to my Word document, my test statistic worked out to be 1.33. Well, you know, we're all lazy, and the reason we're doing this course is kind of to use the software. So let's go to the Stat tab, Basic Statistics. We're going to the pair T. Now, in our case, each sample is in its own column. I don't have summarized data. I got each sample's in its own column. I'm doing last round minus first round. Notice I don't have to give it differences because Minitab is going to calculate these differences itself. Go to Options. I want to know whether the difference is 0 versus whether the difference is greater than 0. Seems to be a pattern here. Now, we're also going to need, this is very important, that we get a box plot of the differences. We'll talk about that after. I'm going to push that out of the way. And here's what I get out of Minitab. Hang on now, I'm going to copy and paste that into my Word document. And when you do the paired t-test in Minitab, Minitab automatically is going to give you individual statistics from each groups. And by the way, 70.9 and 68.9 doesn't look to me like there's much of a difference. And then it gives me some information on the differences. So I don't even actually have to go in and calculate it. It's doing it in the background. Alright, and so if I took the 2 and the 4.5 and plugged that in up here, that's my test statistic. Minitab is telling me that right here. By the way, double check again that you have the right hypotheses, equal to 0 versus greater than. And my p-value is 0.110. Oh man, this is getting to be a pattern. Question again is p less than my alpha? And my alpha is 0.05. And again, my answer is no. Don't be fooled, it won't always be no. Anyway, here the answer is no, and if it's no, we fail to reject the null statement. And if I'm failing to reject, what am I really saying? I'm saying there is no significant difference in scores on first and last round of golf. So no, professional players do not, according to our stats, professional players don't do better on their first round of golf. That's not what our stats are saying. Alright, now, so we have that. And then the other thing is going to be the assumptions. Well, what are the assumptions? The assumptions were that the golfers were picked randomly. Okay, I take all the available golf finalists in the British Open, and I randomly pick 9 of them. But when I do the, when I record the scores for the first and last round, I'm actually using those same golfers, so they're not picked independently. They are in fact picked dependently. Now if they're dependent, which is the situation right here, the big assumption you have to check is that the differences are normally distributed. I already checked, but anyway. Okay, differences are normally distributed. We would go get the box plot of the differences, which you get when you run the paired t-test in Minitab. If you ask for graphs, it'll give you a box plot of the differences. These differences look positively skewed, and it would be wise to run a Ryan joiner on them. So if I come back into Minitab, that's why generally speaking, you do need to get Minitab to calculate these differences, because when I first opened up this file, the differences weren't showing. Now if I got to run a Ryan joiner on the differences, well then I got to have the differences. So I've already got the differences using my calculator. We already set that up, so I don't have to do it again. And now I would go into my basic statistics normality test, and I would check the differences. And because it's a small data set, I'd use Ryan joiner. And Ryan joiner is telling me that the differences do follow a normal distribution because that p-value is greater than 0.1. So, have I met the assumptions? Yes, I have. And that's it for the paired t.